All right. Well, it's 6:30, so I'm just going to get started. Always start on time, right?
Yep.
Okay, so light crowd today, but we are streaming, like I said, so we're going to keep it online for people, and we're discussing Yolo 2 today. I don't know if anybody familiar with Yolo? Anybody use Yolo? No? No? Okay.
I saw their new paper.
Yeah, it just came out on Sunday.
It's like the worst paper ever.
Is it even official?
It's not worst paper, but it's like, yeah, I was bored, it wasn't doing anything, and then I published something.
Exactly.
You ever sitting around and you're doing nothing, and you realize you have to publish something?
Yep. And that
In that style of, I'm too cool to care enough to write a good paper.
pretty much. So he came out with Yolo v3 on Sunday.
It may be great. I don't know.
Well, Yolo, it's actually the precision and the accuracy has all gone up, but it's slower now. So it was a trade-off. So I'm not going to cover it today, like Yolo v3. It just came out on Sunday. I really haven't had time to dig into it. V2 is still way faster, and it's still good for the time being. So what is Yolo v2? All right, let's take a look at this. I'm going to turn the music up just because it kind of helps with the effect. All right, so as you can see, it made a couple of inaccurate views there. You can see one of them was it thought that the gun was a cell phone. Big mistake. But
Please do it sometimes.
yeah, well, you know, the wonderful thing was I love that it really picked out the ties. It did a great job of picking out ties. So that's Yolo 2. Yolo 2 stands for You Only Look Once, version 2 of the software. And I'm going to talk a little bit about why that's special, but I really want to talk about some simple basics that, because we're not having two talks today, we're going to combine it into like a basic talk and then a little more advanced talk. So I'm going to start off with some of the basic stuff here that you would find in the CNN. So in a lot of the computer vision, you have two main things that people do. They have classification and then they have object detection, which are actually very different. So classification is generally you have an item which, in this particular instance, is usually centered in the middle. It doesn't really have a background, and you're really just telling what the image is. So that's a simple classification problem. You see this all the time with little puppies, flowers, and other things like that. And that's classification. And the other thing that you have is something called object detection, because the world operates a little bit differently. So object detection, you have a large, complex system. So you have many objects in space. And then you have to be able to understand boundaries, the differences, and the relations between different pixels within the screen. And you need to be able to tell what the objects are that are seen. So one of the things that you have here is you have CNNs, which we've talked about in the basics before, can do this. Like a traditional CNN where you feed this in and you go through pixel by pixel and you kind of go through the lines. And for each group of, each pixel you create, some classification saying it's, this percentage, that percentage, this percentage, that percentage. And you can go through the whole thing doing that. But the problem is that a CNN is going to be really, really slow. It's not going to have any real performance to be able to do that. And so object detection really kind of took off over the last little bit here because we started looking at RCNNs. And so RCNNs are a little bit more complex CNNs. So generally you have an input image, and then the first thing that happens, you extract these region proposals, which are clusters of different colors, maybe textures, some features, which it kind of pulls together. And I believe it's called a selective sort is the mathematical term for it. And they go through and you get a couple thousand of these, around 2,000 of them. And then that's when you do a CNN on each of these proposals. And then you get your classification, then it comes out and it gives you your classifications here. And these allowed things to move a little bit quicker and being able to do some of the RCNN object detection stuff. It only happened within the last couple of years, and there's been a lot of variations of these. So you've had RCNN, you have fast RCNN, faster RCNN, mask RCNN just came out this year. And so these are a lot of ways of working with object detections. There are a lot of convolutional neural networks, and they're finding different ways to do region proposals, is what they're doing as they go through. Now, Yolo is different because it's not a classifier rebuilt as an object detector. So object classifier would be the normal CNNs, and they rebuild them for object detection. But that's not what Yolo is. Yolo is a completely different way of looking at it and the problem. So why is Yolo different? OK, so let's look at this. So Yolo breaks up an image into a grid of 13 by 13. And it breaks them up all into this. And then what it does is each box that you have here gets about 5 bounding boxes per box itself. So it creates 5 different versions of a box attached to each box, which gives you, in these images, it gives you around 845 boxes total is really what it's doing. Okay? And you can see some of these boxes in here. And so it creates these boxes, just random boxes, and it gives you a confidence score of is this shape, this box that it created, is it any good? And then with each bounding box that it also creates a class. Okay? So you're getting 2 things out of this. So as you can see, for instance, it's tough to tell here, but you got this big yellow one, which kind of goes around our dog, right? We have this red one, which goes around our bike. And in the background there, you can kind of see a car. And that's the confidence score. That's saying that this shape is good. There's probably something in here, right, based upon it, how it pulls these boxes together. And then it combines these to give you a final prediction score. Now, the reason that this works faster is because it doesn't go through and do like all these convolutions and everything like that. It just goes through, at least in the way an RCNN does. It just looks at the data, goes through it once, and just feeds it forward, boom, you're here. That's why it's getting better performance. And somehow, it's getting better accuracy, too. It's still state-of-the-art. Yolo 2 is still state-of-the-art, which is kind of crazy. So, and what I mean by that is you can take a look. I mean, this is Yolo v2. This is not the v3 data, which was just posted. So you have 2 data sets here. You have the VOC and the COCO. VOC is things like airplanes, people. We can look at the names that are in here. There's a bunch of classes in here. And same thing for COCO. They have a little bit different set of classes. But this is a standard class set that people kind of measure against. And so you can look at the Yolo v2. These are 416 by 416 images that it looks here. And you're getting a mean average precision of 76.8, which is actually pretty decent on the original darknet. And the thing here is, look at the frames, 67 frames a second, which is pretty good. I mean, your single shot detectors are usually getting around 40 or 50 in this comparison here, which are a different model that people have set up. And this is the one that we end up using on a lot of mobile stuff, is the tiny Yolo, which is kind of a reduced version of Yolo. So yeah, the accuracy and precision goes down. I mean, and the flops necessary to run it go down. Look at these frames, 207 frames a second. I mean, it's lightning fast. So it's always a trade-off between precision and speed. So, and again on Coco's a little bit harder to train on, but it's still, you can see that the frames are still really, really good on this. And so that's one of the reasons that people like Yolo. Now, Yolo is going to be, let's see here. There's a lot of different versions of Yolo. That's one of the challenges. So, in case you don't know, Yolo is based on a system called Darknet. And Darknet is written in C. So unless you know C, you're not going to be able to go in and really do a lot of work with Darknet, which is one of the things that I had to go looking at some other places, because I'm just not a C person. Okay, there's people who are, and they could get really good times if they modified something like the original Darknet. Now, this guy Alexei AB, he created a good Windows Linux port, which a lot of people use. And so I'm going to show that one. And there's PyYolo, which is a basic Python wrapper around the C libraries. And that one's not too bad in terms of speed. So for an object detection, normally something like Darknet could do it in around 0.02 seconds, something around there. And if you do it through PyYolo, I think it goes up to 0.08. So it is slower because you got to go into C and out, or into C and out, especially when you're doing looping and stuff. So you do lose some speed when you go into Python, which is a shame. Now here's another one that people like, DarkFlow. They like TensorFlow. Now, if you are familiar with TensorFlow, this is a great version of it because of the programming paradigm. You can also look at PyTorch YOLO 2. Now, as someone once said to me, this looks like it was done by a bunch of Korean grad students. Like a lot of the PyTorch YOLO 2 libraries there's like 7 or 8 of them. And they all kind of are similar. But this is the one that I found that actually is closest to getting the normal performance. So if you like PyTorch, this is a great one to use. Now, Cafe YOLO, unfortunately, is really outdated. And there really hasn't been too much done with it. And it seems like people are kind of moving away from Cafe in a lot of ways, at least for YOLO. Like, it does have its place, for sure. Okay? So actually, let's take a look at some of these real quick, just so you can see. This is the common one that you're going to get here is, if you're going to use this on your Linux, and I highly suggest you use Linux. You can use Windows, but Linux is going to give you a lot more options here. So this one here is, let's look at PJ Ready here. So this is the actual Darknet site. That's a little Darknet symbol. And here's the YOLO 2 site. And you can check it out. He actually has a new video, which does not have as much heavy metal music to it. And here you can see some of the speeds. And here's some of his data that you have on the new version 3. So as you can see, he doesn't get as many frames per second. This is actually on Coco. So, but a lot of this is in C. So this one right here, if you're looking to do a lot of Windows Linux work, I would highly suggest looking at this port of it. It's very good. And one of the things I really like about this one is if you look at the issues, he just doesn't close the issues, but he answers almost every question that somebody asks. So there's a great community here, a great response. The Darknet group does have a couple of Google groups that you can go to, but for the most part, this is just an amazing community and a great group of people if you want to learn how to use Yolo. So that's one of the reasons that I recommend taking a look at that one. What else do we have here? Yolo, not much to show. Dark flow. A lot of people really like TensorFlow, and I like it for a lot of stuff. In this particular instance, I'm going to show you. We're going to take a look at these libraries. I'm actually going to show you how Yolo looks on them. And hopefully, because I am streaming at the same time, we can get a little bit of performance out of this. We'll see if it actually happens. But this is the dark flow, but it's kind of slow, just like TensorFlow. But yeah, so, but if you use the TensorFlow, I mean, you have your, everything kind of runs the same way. See, it's well documented, which is one of the nice things, and you have your built graph already there. So like, it's pretty good, and it ports the weights. So, okay. So here's what we're going to do. So we're going to do an out-of-the-box demo in checks. So I'm going to show you it working on here. I can't show you, obviously, working on it, which is unfortunate. So you don't get some of the cool, awesome speed stuff, but we will be able to see it working a little bit, just to see kind of the process and the methodology and how you would work with it. And then we're going to customize, talk about how to actually customize and build your own classes, which is what a lot of people want to be able to do. Like, how do I get this thing to do my own stuff? And so we're going to take a quick look at that and how to go through the process from annotating your images, how to train it, validate it, and then we'll take a look at our tests. I'm a big fan of Jack Skellington, so we're going to do that. But let's take a look at this demo stuff here. Okay. So I have Darknet set up here. Now, Darknet has some challenges on the Mac. Works great in Linux, like if you're using Ubuntu or something like that. Works awesome. So it's not the best performance here. Oops. Okay, so in order to keep this, let's just take a look at a simple image classification. Now, I had these pre-done so that I can go through them so they don't take too long. But essentially what you're doing here is you're calling Darknet, which is the app, right there. And we're going to use a detector. So the detector can do all kinds of things. In this particular instance, we're going to test an image. But it can also demo and do some other things, train. So we're going to test. Now we have a configuration. Okay, so let's, these configuration files we're going to look at. They're always the same. Okay, but if you go through and you do a lot of this stuff, you'll end up doing a lot of these. So this is a .data file. So in this particular instance, they're using voc.data. I'm going to show you the skeleton one because it's all the same. So basically, you tell it how many classes you're going to be training on. You tell it where to find your training and validation set, where to find the names, and where to store the weights. That's all this data is. So it's going in and picking out that information. Oh, how many classes should I have? And then it's going through and saying, OK, well, what are the names of those classes? In this case, it's Jack Skellington. When you look at voc.names, it's saying these are the VOC listings. Airplane, bicycle, bird, boat, bottle, et cetera, et cetera. I don't know who came up with this list, but maybe it was just easy to annotate. And then we're going to supply it the weights. And then we're going to say, OK, where do we want to look? So it comes with this image of a dog, right? We saw this one. So there it loads all the models, loading the weights. Bam, there it is. And it says, OK, so it loaded up the models. The model, which is it's really nothing, it's just a simple convolutional model. And then it loads the weights and it tells you the predictions. So here is the confidence score, 78%, 55%, and 50. So it split the car in two. Oops. okay, but it did get 78% on the dog. Missed the bike though. Oops. It is what it is. So this one did miss. It's hard to believe this is state of the art, huh? But it's pretty good in the world. So that's an image. Okay, well, how do you do a webcam or a camera? So we go through, we're going to use the same weights, same configuration file, same data. And instead of saying detect or test, we're going to do a demo. So again, we're going to load the model, loading weights. We're going to look at the webcam and see what kind of performance we're going to get. My guess is this is going to be terrible, probably 0.2 frames per second or something like that on this laptop. Not 14,000, I know that's what comes up, but you know. Okay, so it's getting me 0.3. Yep, but it's identifying me at 0.4 frames a second. Yeah, okay, awesome. So that's what I was looking for. Okay, so not great on a laptop. Okay, not great out of the box. All right, so let's close that one out. Okay, so let's look at out of the box. Okay, let's look at PyTorch Yolo 2. I actually like this implementation. I'm using Yolo in my implementation that I'm using on in production. I'm thinking of switching, but it seems to work okay. But PyTorch Yolo 2 is actually pretty close. So let's look at this one. So again, PyTorch Yolo 2, this is the Marvis. So this is a pretty good setup here. And we're going to use all the same weights and same configurations. And it just converted to Python and just wrapped the C libraries is what they did and put it into PyTorch. So as you can see, it's loading the same libraries. There we go. It's a little bit faster. Now, I think that's just because of the way Darknet got hooked up on this one. Obviously, it's usually faster. I've gotten it on the laptop to around 4 frames a second. This is a little bit faster, or a little bit, this is good. You're generally getting 3 to 1.7, somewhere in that range. Okay? And then you can see the confidence scores that it's given you, person. It's pretty confident that I'm a person, which is good. You know, I've heard that. It's not the case sometimes, but oh, it picked out a TV monitor in there. Okay, that's good. So as you can see, it does pick up a number of things, which is pretty good, and then puts the box around and the styling. Now, this feed, by the way, this display is all done using OpenCV. That's how it goes through and displays it to you. So you will want OpenCV if you want to be able to review this, and preferably compile it with CUDA. That's something that I do beforehand. Okay, so that was good. Okay, good job, PyTorch. Now let's look at Darkflow. And Darkflow has a little bit different setup here. It's a little bit, terminology is different, but you can see the weights are all the same, the configuration's all the same. It's got to load up, good old TensorFlow. Slow, slow, slow. Using leaky reloos. Reactivation functions, here we go, almost there. Come on, TensorFlow. Okay, good job. Now, it should give me a frames per second. There we go. So we're looking at about 0.784, which is really slow. But that's TensorFlow, okay? TensorFlow has been, it's one of the knocks on it has been, it's been slower when you get on devices with not a lot of capabilities. TensorFlow Mobile is looking to fix that, and I think I'm using TensorFlow 1.5, I think, on here without compiled with CUDA, so you know that's going to hurt. But as you can see what in real life what some of the challenges are. So each of these are going to have their own unique challenges. TensorFlow is easier to use for a lot of people. It's great for prototyping. You can go really far with TensorFlow, but it does tend to be a little bit slower on devices that don't have any power. So, awesome. Okay, so that looks good. So that takes care of that. That was out of the box. Okay, so But how do we customize our own stuff, right? How do we do things that we want to train it on? So this is where it gets fun. Now, first thing you have to do is you have to collect your data, okay? Ideally, I would say 2,000 images is a good start, okay? And you want it to be fairly representational of what you're doing. So if you can't get to 2,000 images, then you're just not going to see the accuracy that you want. So today, I'm not going to train it, but I'm going to show you how I trained it on on Jack Skellington. And I trained with about 75 images. So not great. I'm not expecting huge performance. It didn't train incredibly well, but it'll show you the process, which I think is what is important for everybody, to be able to do this on your own. So let's take a look here. OK, so I'm on a Mac. Now, you can use something called Yolo Mark, which is on the Alexi AB. He has a link. He's a tool he created called Yolo Mark. Yolo Mark. Yep. And it's its own GitHub repository with its own instructions about how to set it up. I've used it before. It's pretty cool. I mean, it's for a Linux tool. It's pretty nice, actually. So you can use that. But I'm on a Mac, and it's slow. And I want to be able to have like 4 or 5 people be able to label with me. So I'm using a program that I can quickly just duplicate on people's machines. So I got this program called Rect Label. And it's $1. I know you have to pay for it, but I'm hoping you can afford $1. He deserves it, whoever designed this. So what you do is you open up a folder. So in this case, I'm opening up the training Jack Skellington folder, right? OK, so it's open. So this is the first image. And what I need to do is I need to be able to label it. So in my settings, I'll go through and I created a new object called Jack Skellington. And so in here, I'm just going to highlight him. Try to get it as close as I can to him without missing a piece. Okay. So that looks to be pretty good around Jack, right? So then what do? I go to the next slide. And I can just import the same location if that's helpful. In this case, it wasn't probably helpful. But if you're doing like a video series and you have like 60 images that are like pretty close, you just need to change it like a minuscule amount, that's very helpful. And there you go. So so it tells me how many images I got. I got 70 in this data set. And then I just go through the whole data set and I label all of these. So I've already done that. So I'm just going to load these so you can kind of see what they look like here. So it puts it all in this file called annotations, which I'm just going to delete here, copy. Oh. Undo. There we go. Wrong folder. Go Finder. OK, so now it's in there. So now if I go in here and I open this folder again, you'll see that all these should be in there, right? Because I went through and labeled all of these. And so what does it look like? Well, it creates this XML file. Oh, crap, it's opening Xcode. Hold on. It might crash my machine. Yeah, so I forgot to mention, I'm trying to, we're working on 3 different systems here, so it might take me a second to get them all working in order here on this little laptop. It's going. There we go. OK, so this is what the XML file it produces. So the rect label basically gives you a height and width of the image. And this is depth. That's how many channels. They always have 3 channels unless it's a grayscale or something. And then it tells you the bounding box. It gives you the coordinates of this bounding box. That's all it does. It creates this XML file. It's very useful, okay, for later on, okay? So that's what you need to do. So if you're going to do 2,000 images, think about how long that's going to take you. I can tell you about how long it's going to take you. It's going to take you about 5 to 7 hours to get through 2,000 plus images. And that's if you're cranking. So some people like to outsource it to somebody. Like you can go through Upwork or Upworthy, I think it's called now. One of those used to be Odesk, for outsourcing. You can go use that, or you can just get an intern to do it, right? That's intern work right there. So, all right, so we labeled our data set. So that's the first thing that we do, okay? Now, the next thing is we got to convert these, because that's not what Yolo actually wants. Yolo has a special format that it uses. So let's take a look at this real quick. So I'm just going to show you, I've gone through and done all this already. Oops. Nice picture there, Jack. So this is what actually Yolo wants. So Yolo wants a class. In this case, it's the 0 class, whatever that is, right? And then it tells you what percentage of the image. So this particular image, started at 0.5% of the height of the system, right? And then it goes to, and then this is the left, I believe, is 0.5. And then it goes to 0.93. So this is by percentage. It's not by points. So it's not by pixels. So you got to convert from pixels to percentage, okay? Now, the nice thing is that it's pretty, there's something called VOC label, which it comes with. But we can quick open this up. I just want to show you. I've modified it for my own purposes. So these are some of the ones that I use for. Okay, so it's an easy Python script which just takes a path in it. Now, this is where I pick my classes. So this is why it knows to choose class 0, because Jack Skellington is the first item in that array. I could put Jack Skellington, rich, person, Lancaster AI, right? And it would say that this is, when it goes through and creates it, it says if you identified these in your labeling, right, then this would be object 0, object 1, object 2, object 3. That's how it knows. So you just change this. And because I'm on a Mac, I had to take care of all this crap, which unfortunately DS Store and a bunch of other stuff. And then it'll just go through and create those text files, which I just showed you. These text files, these guys right here, it'll create these for you. Percentages. Okay? And you may be wondering, oh, how am I going to ever keep track of this stuff if you want to do it on your own? That's why we're recording it, so you can go back and watch the video. Right? This is as much for me, because I do this all the time, as for all of you. You can go back and watch the video. You can also go to this great, this is an awesome web page, how to train YOLO 2 to detect custom objects. These guys have been awesome. They have their own scripts that they use as well. They're not, if you're on a Mac, you're going to have to modify, but they have a good process here. All right. So I hope you're still following. Okay, so that's annotating. We're using rect label. So then what we need to do is, and then we process. Where is that guy? Okay, so the next step that you have to do is you have to set up the system to know what to train. Because okay, so you labeled everything, and now you have your text files, which say, okay, in this image is these objects, and this is where they're located. The next thing you have to do is you have to tell YOLO, okay, how do you find all these images to load into your models? How do you load all that stuff into the training? How do you load it all in? It's all in these blog posts, so you can follow along. They have a great file. It's a great script. It's called process.py. I have it available in my GitHub. I'll post this for people so you can have this. But this one I kind of borrowed from that blog that I showed you earlier and modified it for my own use. But it's a quick Python script here, which is just taking these images, going through and cycling through and just creating, taking the path data and locating everything in a path. So it creates these files here. These, let's take a look which ones. It creates these files. Just takes a second to find them. A train file and a test file. So this is what the train file looks like. So remember the path I have here. So here I have this path data. This is on my Ubuntu machine. And so it lines up with this. And these are the names of the images. So this one was 86 blah, 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 blah. You know, these are all my Jack Skeleton images. This is where it can find them in relation to Darknet. So Darknet can say, I need to grab this image. And then it can go in and say, OK, I grabbed the image. In this image are this object at this location. And then it'll train, and it'll go through all of those. OK? So that's, now you have your training stuff. OK, I can't train it on here. It would take forever. So, handy dandy, I created a little video of what it looks like training. Now this isn't going to be super exciting, but I'm going to show you something here real quick. So this is on a Ubuntu machine. You can't read it because it's so blurry, but basically, see how fast this is going? It's going nice. Now I'm going to adjust the exposure here real quick. So you can't read this because it's blurry, but this is about 42,000 epochs, which is a long time, okay? But it's going pretty fast. Every couple of seconds, it's going through. So if you're going to train this on any data set, I mean, I've used it on 10,000 images. It usually takes about a little less than a day to train it. So, and this is your average loss. It's tough to read on here. I'm sorry. You'll be online. You can see it. But this is dropping. This is about 0. It started off at 10 and it's dropping down. Okay, and this is, we're going to see, it's tough to see here, but the little dots are starting to collect here. In fact, but this is what it is to train. So basically, you set something up, you process it, set it to train, and you go do something else for a day, is really what you do. I mean, you can watch it if you want to come back and just say, oh, that's awesome, good work. But essentially, that's what you do. So a lot of these things do take a while. So you want to make sure you get this step done properly so you don't have to redo it. Okay. So what does it look like at the end? So this is kind of what it looks like at the end. So this one settled in pretty quick, right? So this one settled in at right around here. This is 4,000. I would say probably around a little bit before 4,000. Here you see a little bump. It's probably starting to overfit there. Probably starting to run into some problems. I stopped it at 20,000 for Jack. This is just, it's a really small data set. Honestly, it probably started overfitting here, but that's so what that does is you get all the weights. It saves weights every 100 epochs, so you get all of these. Okay, great. So then what do you do? So I trained it. Well, the next thing that you do is, how about you validate it? You say, okay, well, how good did I do? How well? Sorry, that's the wrong English. I know some people would hurt me. How well did you do? Okay. All right, well, here's how well you did. So I'm going to use the Alexi Darknet. Darknet Alex, right? Alan's it. And I'm going to use his validation tool because it's actually pretty good. And so let's look at 1,000. So I already transferred those from my Ubuntu machine here for demonstration purposes. So let's look at the first 1,000 epochs. So what does that look like? So again, if you're using Yolo, you can see detector, darknet, call the app, detector. We're using the same piece of the app. And then we're going to use the tool. So we're going to use map, which is the mean precision. And then we're going to send in the data, skeleton data. We're going to send the configuration, and then where the weights are. It's always the same. Always the same. It looks like a lot, but it's really not. Okay, so it's loading its weight. Now look how slow this is. It's going to take a second. Remember how fast that GPU was going? It's coming. It'll happen. I promise. There we go. Okay. So let's take a look at what it told us here. Okay, so here's that class ID. Remember the 0 in all those text files? All these guys here? These percentage that we created with our VOC label.py? Well, that's the ID. What was the name of it? Jack Skellington. And it's not bad, you know, for this. Now, threshold. So let's describe this real quick, just so you know what that is. A threshold, remember that big Yolo image we had with all those boxes on it? There was like 845 boxes. You remember? And there's just a ton of stuff. Well, it only shows things that have a certain prediction level above a percentage. So if 24%, it's confident that this is 24% probably this, it'll show that. You can set it as high as 50, 60, you know, if you don't want to show much, or you can set it really low down to like 10 if you really want to show a bunch of stuff in there. So but for tiny YOLO, which is what we're using, the threshold is 0.24. It'll show everything that it's confident that this is 25% at least probability that this is it. And then your map score is around 60.94. Not the greatest, okay? But the precision, 0.75, recall, it's okay. So let's do the same thing, but let's look at the 4000. And we're going to run it again. And let's see if we can make this bigger so we can possibly see both at the same time. We'll see. If I was running them in separate windows side by side, that would be easy. I should have done that. But here you go. Okay, so you can see the differences. So most of my scores are, for this threshold, are a little bit higher in this one. Precision's a little higher, recall's higher, the F1 score's higher. Precision's actually a little bit, the full mean average precision's a little bit lower here. But I'm going to go with this one just because it's probably overfitting a little bit. But some of the other scores are a little bit better. So I don't think with this little of a data it's going to matter much. So let's take a look at how this performs. All right. So let me take a look here. So we looked at those. Okay, so we're going to do it in PyTorch because all the other ones are really slow on this machine. Okay. Again, so we're using a Python demo py. Here's the configuration, and then we're just putting in the weights. This worked at my house, so we'll see if it works here. The true test of a demo. All right. Ooh. Well, so far it hasn't said I'm Jack Skellington, which is good. Let's see if it picks this guy up. Hey, look at that. Jack Skellington. Not bad. I think it's picking it up in the, hold on, let's get it out of this screen here too. All right, so it's getting at about 2.8. Let's get it in front of the screen here. Okay, there we go. So, not bad. All right, but it's really slow, taking forever. Obviously, if you're doing this for a security camera, where you only need like 1 frame a second or maybe 2 frames a second, like if you're doing it with a Raspberry Pi and streaming it back somewhere, you could probably be okay with that. I like those things. I'm Jack Skellington too. All right, so it's not perfect. Obviously, a lot of work to do on that. But that's generally the process about how you would go through and train your own classes. And you can go through, I'll post some of this stuff up for people to follow if you want to go through and do this on your own. It's not that difficult. The only challenging thing is finding a good GPU, making sure it's set up with CUDA. You're going to need CUDA and CUDNN, right? And they are challenging. to get set up still, even on Ubuntu. I'm using Ubuntu 16. I posted a couple of things about getting the new OpenCV. You're going to need OpenCV, CUDA, and CUDNN installed. Okay. If you've done any AI work, you probably have already done this. But you can set it up on yours. Get a GPU. It doesn't have to be a super awesome one. I know there's a real shortage today because of all those stupid miners. But you can get a 1060 or a 1070, just fine, usually. And you can start running these and doing your own data sets. I can tell you right now, there are tons of companies being built with Yolo too, because the licensing, well, let's just say somebody mentioned earlier about his papers being a little unprofessional in terms of how to release these. So, which is true, but I think it's part of his personality in some ways, because what he has here, let me show you his licensing for Yolo 2, is, yeah, how about that one? I heard you like licenses. He's very open with his licenses. You can do whatever you want with this, which is actually pretty incredible. There's not many things like this out there that you could do, like completely commercialize it and have a good setup. If you know C, I would highly recommend digging into it. This is a fabulous modeling setup for that. So that's about it for what I have for that. So 45 minutes, which is a little bit longer than a standard talk that we have here. Probably be about an hour before we finish questions, so that's good. So why don't we close that right there. Let me see if there's any questions online. Yeah, I don't know how he gets all these cool things in there. I kind of like that. So, all right. Let's see. Nope. Okay, good. Okay, so I'm going to open up for questions. Does anybody have any questions about Yolo, setting it up, running it, anything in general? Anything out there for people? Yeah.
You said it was state of the art.
Yeah.
Like, is that like some sort of speed versus accuracy ratio going on there?
I mean, that's very subjective.
Yeah.
It's a subjective term, sort of like this is awesome. But it does have probably I would say, yeah, the best trade-off of accuracy versus speed. I mean, it is just fast, especially tiny Yolo. But the thing is, okay, yes, it does have some challenges with, let me show you an image with Yolo 2. So I picked out the horses where, no. Oh, here it is. So that's one if you had the by the way, this is an image if you had the threshold set to 0. All right, so that's what that does. All right, so here's tiny Yolo. So it turned that into a sheep. This guy's a cow, or this dog's a cow. Okay, not the greatest feature set to be pulling from, especially if you're training your own weights. But you could do something with it. Man, is it fast, especially if you're just doing pedestrian detection. Like all you need is people. I mean, you can pick up a lot of people very fast. I mean, you saw the video. So, people have, for instance, you could set up something where you'd be able to look at a group of people, count them up to see how many people are in a particular area and feed that somewhere. With something like Yolo 2, could do it really fast and quick. And yeah, I mean, so that's why a lot of people consider it state of the art. I'm not, I'm finding actually some challenges with the precision. And I'm finding that I'm having to feed it a ton of data. Like I should only have to do, a lot of people saying they're doing 2,000 to 2,500 images for a class and getting good map scores, but I'm not. And even when it's in the wild, which is where it actually matters, like monitoring to say, is this person? you know, and you feed it a lot of images, and it either does it or doesn't, you know. And so working through that and figuring that out has been a little bit of a challenge, but for a lot of data sets, it's better than a lot of stuff that's out there. Yeah. Other questions? Thoughts? Anybody? Easy peasy. Yeah.
Tried inflating the training data sets to 75. That's you flip it and flop it and have fine transform.
Yeah, so augmenting the data. Yeah, so you can do that beforehand. I think it's helpful. It does randomize the resolutions. Like you can set a random score when you do the training to randomize the resolutions, which helps. And I'm actually looking at myself of using some GANs. I actually spoke with Wes earlier about that, to use GANs to modify some of the data to just really blow up the data sets and see how that works. That's kind of my next step, I think, for what I'm doing. But yeah, augmentation, I think, is definitely something that you're going to have to do with something like Yolo, which just blows right through, you know, the images. Absolutely. Yeah.
Do you have other knobs you can turn on Yolo to tune it to make it better?
Oh, I'm sure. I mean, what do you mean by noms?
Like hyperparameters.
Yes, there are some in there. Is there anything in particular you're looking for?
I'm just wondering, like, what kind of options you have for improving the accuracy just by, I don't know, trial and error, validation sets, things like that, and hyperparameter grid search or whatever.
I haven't played around with them too much, honestly, in Yolo. I'm sure they're in there. I just haven't done it myself. That's Yolo Mark. That's PyYolo. What's
Have you checked out Facebook's Detectron?
I haven't yet.
It's probably not as fast at all, but it might be worth looking into.
What's the other technical term for hyperparameters? I can't remember off the top of my head.
Parameters.
So, you can change the models pretty easily as let's see what's in the config. There are config files that you
like
can
the
put.
size of the
Yeah, like the size of the images. Yeah.
Yeah, like the number of hidden layers and
yeah, all that stuff.
cognets and,
Yep. So let me look here.
comp layers.
So these are, I'm going to use this one because this was tiny Yolo. But this is just an example of some of the configurations that you can change. If this is what you mean by hyperparameters, like change of decay, all that stuff, how it modifies the images, the learning rates. Now, I haven't played with their learning rates because you could get the dynamic learning rates from PyTorch. I really think there's a lot of potential to use Yolo, the Yolo stuff with PyTorch and the fast AI libraries because they have a lot of dynamic libraries to really speed this stuff up. I think there's a lot of potential there. I just haven't had a chance to play with it myself. But here's where you can go through the configs and you can change a lot of that. So it's pretty straightforward to go through, you know, and really it's just convolution pooling. Nothing real amazing here. I forgot about this. This is one thing that you might want to do. If you do your custom set, you do want to reset the anchors, which is how it sorts the bounding boxes. That's in the blog post that I put up there, but that does help. It actually boosted my precision by about 5%. So
It kind of auto-generates those based on your data set?
it's based on the Yolo, each one, so Tiny Yolo has its own set of anchors, and if you use that feature set in your own, so like you use those weights to start building your own, you need to reset those anchors for your data set. It's really easy. It's just a quick script that they have in there. It's kind of hidden in the Q&A stuff that they have, but here's that random I was telling you about where you can set it to do some of the data augmentation. It's all in the config files.
Nice.
Another thing that you can do if you want to increase your precision is you can increase the actual image size. It resizes everything to 416 by 416, which isn't bad. And that's how it gets a lot of its speed. You can go up to probably 608 and still get real time, 30 frames a second. Anything over that, I mean, it's going to be really tough. So any feeds that you have coming in there are going to need to be downsampled pretty quickly. So you have to figure out, how are you going to downsample stuff if you're doing a live feed, how you would do that, like your webcam or, anything like that, if you want to increase performance. Cool. Any other questions? Awesome. Okay, cool. All right, well, thanks, everybody. Quick and easy today. Some quick announcements. So next month, I'm working on moving this to the Hambright Elementary School because we're trying to get the high school kids involved. So we're going to try to start getting the Penn Manor School District involved in a lot of these things. We're going to see how it goes the first month. It hasn't even been approved yet. But we're going to try to do that. And I think it also might be helpful to not have it next to a bar. I think that might be helpful for some of our people who might want to attend. And so we're going to try that out next month. Also, announcement for, I don't know if any of you know, the Lancaster Ben Franklin Tech Accelerators, which is a state economic development program, is having a launch party this Thursday. They're starting a new incubator here in Lancaster. I attended as part of this SUGI back in the fall, so September to November, and it was a great incubator program. They're opening one up here in Lancaster, so if you want to start up your own company, it's something that you want to take a look at becoming a part of. They're teaming up with the Candy Factory, which is a great shared working space. There's probably 100 to 200 people over there. They got a big grant, $350,000, I think, to set it up over there if you want to head over there. But it's going to be this Thursday. You just need to register. And I know there's going to be a lot of interesting people out there, a lot of state reps, a lot of people in the tech community, people from Ben Franklin. So it'd be a good opportunity if you're in tech and you want to be part of the growing tech scene here in the city, that you would make it out. So they're not paying me for that, but I just want to put it out there because they did a lot for me, and I always want to be able to support them. So I guess that's about it. Awesome. Thanks, everybody. Hope you have a good night. And stay tuned to the website for information about next month and what we'll be doing. So thanks.
Cool.
All right. Oop, there we go.